Hello friends, in this video I am going to explain CPU scheduling algorithm in operating system. In my previous video I already explained you FCFS CPU scheduling algorithm with the help of example. In this video we'll see SJF, that is shortest job first, with the help of example. With the help of this example we will see how to draw Gantt chart and how to calculate average waiting time and average turnaround time using SJF shortest job first algorithm. Now we'll see same example with preemptive SJF. In preemptive SJF, the process, if newly arrived process having small burst time as compared to currently executing process, then currently executing process gets preempted. So in the given problem, at 0th process P1 is arrived, so immediately process P1 is scheduled, but at 1th process P2 is arrived. Now in this case, as it is preemptive SJF, so process P1 is get preempted because the remaining time of process P1 is 7 and burst time of new process, that is P2, is 1, which is small as compared to 7. So here process P1 gets preempted and process P2 gets scheduled. So burst time of process P1 is 1. So process P1 executes or completes till 1 at till 2. At 2 process P3 arrived. Now currently there are two processes P1 and P3. The burst time of process P3 is 3, which is small as compared to P1. So process P3 get scheduled. Then at 3 process P4 is arriving, but the remaining time of process P3 at that situation is 2 and the burst time of process P4 is also 2. Here tie-up occurs. In this case, if tie-up occurs, processes are scheduled according to their arrival order, means according to first come first serve basis. So as process P3 come first, so it gets scheduled and continue its execution till 5. If we observe that at 4th process P5 is also arrived. Now we are comparing the burst time of process P3, that is remaining burst time of process P3, which is 1, and the burst time of P5 is 6. So the burst time of remaining burst time of process P3 is also small. So process P3 will continue its execution till 5, and after that we can choose the processes simply based on their burst time, comparing their burst time. So burst time of process P4 is 2, so it is P4 is 2, so it is scheduled first. Then burst time of P5 is small as compared to remaining burst time of process P1, so process P5 gets scheduled first, and lastly only process P1 is remaining, so process P1 gets scheduled and it will execute till remaining time, that is 7. So as it starts at 13, it will complete at 20. Now we'll calculate waiting time same as we discussed. So process P1 is executed in two halves. So at first process waiting time of process P1 is 0. At second time, when process P1 starts execution, it is waiting till completion of P2, P3, P4 and P5. It means 13 minus 1. So waiting time of P1 is 12, P2 is 0, P3 is 0, P4 is starting time is 5 minus arrival time 3, so equal to 2, and P5 7 minus 4 equal to 3. Simply make average of this waiting time, will get answer 3.4. Same way, now, as explained previously, we will calculate turnaround time with the help of waiting time plus burst time. So, as we already calculated waiting time, add waiting time of all these processes in the burst time which is given in the problem. So, turnaround time of process P1 is 20, P2 is 1, P3 is 3, P4 is 4, P5 is 9, average 8, and we'll get average turnaround time as 7.4 milliseconds. Now we'll see SJF non-preemptive algorithm with the help of same example. So in this example, at 0th, process P1 is arriving, so it gets scheduled. At 1, process P2 is arriving in the system but not get scheduled even if it has small burst time as compared to P1 because we are using SJF non-preemptive algorithm. So after completion of process P1, process P2 gets scheduled. If we observe the information given in the problem, till completion of process P1, all processes are arrived. Now, here we are only going to check the burst time of the process. The process which is having small burst time will get scheduled first. So accordingly, as process P1 having burst time 1, it gets scheduled, then process P4 gets scheduled, then process P3, and lastly process P5 get scheduled. Now we'll calculate waiting time of all these processes. As process P1 arrived at 0 and get scheduled at 0, so waiting time of process P1 is 0. P2 is 8, which is starting time of P2. 8 minus 1 equal to 7. Waiting time of P3 is 9, P4 is 6, and P5 is 10. We'll make average of this waiting time and we'll get 6.4 as average waiting time. Now we'll see turnaround time of all these process. To calculate turnaround time, we are adding waiting time plus burst time. Here we already calculated waiting time of all these process. We are going to add waiting time with the burst time of that process and we'll get turnaround time of that process. So accordingly, turnaround time of process P1 is 8, P2 is 8, P3 is 12, P4 is 8 and P5 is 16. We'll make average of this turnaround time and answer is 10.4 millisecond for average turnaround time. So these are the references which I used. Thank you for watching this video.